My name is Ingo Flömer. I'm based in Germany, and I am responsible for product management in the Europe, Middle East, and Africa region. So our agenda for today is an introduction to Axel Wireless, and we keep it short because we want to concentrate on the main topic, which is idDAS. What is idDAS? How does it work? What are the benefits for you, for our customers? Example deployment scenarios to show you what are likely examples where you can take advantage of digital DAS, show some product details, and finish with a question and answer round. So let's start with Axel Wireless. Who are we? We are a global company based in the UK. We have several R&D plants around the world. We have a large grid of service and sales offices around the world. We are a manufacturer for DAS and wireless coverage solutions. We fully concentrate on active solutions. So we do not sell cable, connectors, antennas. We fully concentrate on the active part of the DAS. We are part of COPEM. COPEM is an industry giant, a 3 billion company listed at the London Stock Exchange, strong in defense products. And we are forming a new business unit with COPEM very soon, COPEM Wireless. So we are providing solutions for cellular, public safety, and transport applications. Basically, we divide the business in these 3 columns, and the biggest growth is in cellular, and idDAS is clearly focusing on cellular. The roots of our histories are more than 40 years old, and Axel Wireless is known as the market leader for public safety products globally. We have increased our activities in the cellular market over the last 5 years a lot, and now have quite a good market share and a strong growth in that segment. We are clearly focusing on quality, and that means we need to be inventive. We come out with new products basically all the time. And what I use as a reference when it comes to quality, obviously, is related to cost. Quality has higher cost than no quality, but my reference is always that we are used in most of the Chinese metros for public safety products, which is a good sign in a low-cost market to be present as a quality manufacturer. COPEM Wireless, our mother company. In this year's Mobile World Congress, we announced that we will be fully integrated into COPEM by July 2015, which is next month. We will form a new business unit, which will be called COPEM Wireless, and we do that with Aeroflex, another well-known company in the wireless market. They focus on test solutions and load generation solutions. So this will be an excellent combination where we can share skills and have a similar market appearance, low quantity, high quality products, and we take advantage of this knowledge base that we create with it. For us, the advantage is that we get access to the latest standards upfront, because the test equipment guys have to have this much earlier than we need it, and this is a great benefit for us. So for you, nothing will change. Axel products will remain the same. The staff that you are used to contact will be the same. The offices are the same. Just the name will change. Name and email addresses will change to COPEM Wireless. So we are now in more than 150 countries, serving more than 170 mobile operators. It's probably much more by now. 16 offices worldwide, which is not covering the whole world, obviously, with 16 offices, but we use a large rate of partners, of companies representing us, adding value to the product, adding components like third-party items, cables, connectors, antennas, and so on. So currently we run our operation with 250 staff, and that is because we have outsourced large parts of the production, and that makes us lean and able to react quickly. Latest ABI research shows that they list us as innovation leader in the DAS market, which makes us proud. ABI Research is a company analyzing the global market, and in this case they did it for in-building solutions. DAS solutions, and due to our idDAS innovation, we were listed as innovation leader, which makes us really proud. You see some companies stronger than us. So idDAS, focus now. idDAS is a digital platform for distributed antenna systems. It is a revolution in the market. It's the perfect storm for mobile operators. And why is that? We see this huge growth in data traffic per individual user, per network. A typical growth rate for a cellular network is 100% per year. This sounds already quite high, but if you look on a 3-year cycle, it means you have about 10 times more data throughput in a typical cellular network nowadays. So that means operators need a solution that allows them to operate more effectively, because at the same time where the deployments grow, the ARPU, the revenue per user, is not growing very much because most of these offerings are run on a flat rate package. So there is a problem in the industry. There is no funding for more investment, but rollout is required to keep up with the data growth. And for that reason, we believe a new approach needs to be found, which has a higher efficiency, which reuses resources in idle periods. And that's why idDAS was born, to basically allow to shift capacity to where it's needed and when it's needed. Because the challenge today is that the traffic behavior over time, over a day, over a month, is quite sporadic and bursty. That means you have idle periods in a metro system in the late morning, in the afternoon, and then it's followed by a peak period in the evening, and the late afternoon, early evening, and the peak period in the morning. So it's not really balanced. While an office building might have a totally different traffic behavior. It's empty overnight, then it fills up in the morning, it's full over the day, and gets empty in the late afternoon. So it's this opposite traffic cycle which should be used. And this is what we show on the next slide here. We try to balance the traffic load over time in the overall network. So this is not an individual building anymore. This is a cluster of a network. It could be an entire city, for example. And sharing capacity between sites means balancing the traffic load over time. So idDAS is an intelligent digital DAS. It's an exciting, cost-effective way for mobile operators to handle the challenges of capacity management. idDAS allows to dynamically allocate capacity where it's needed, right-sizing the capacity and using only where and when it's required. This word dynamic needs to be explained further. It doesn't mean that idDAS is doing what idDAS wants to do. idDAS basically follows scenarios that were preset by operators, considering neighbor relationships and all aspects that you need for network planning. It could be based on time schedules. It could be based on preset scenarios, for example, in the stadium, when you exactly know now this fills up and you preset it for that time, or it could be based on traffic measurements. So idDAS allows capacity to breathe. It doesn't need to be hardwired, and this means a reduction of CAPEX and OPEX. So let's take some scenarios to make it better understand it. We take here a case study. It's a typical mix of buildings, large buildings, offices, shopping center, hotel, restaurant, and underground parking area. So this is a typical scenario we find in many countries now, and the new projects are being built all the time. It's like a campus. And currently, we have a certain amount of capacity that we pump into these buildings. This capacity is hardwired because this is an example using traditional DAS. For example, the green sectors are feeding a shopping center. The orange sectors are feeding a hotel. The blue ones feeding a convention center, and the green and yellow ones could be an office building. But it's hardwired. You can't change it, and every single color needs to be dimensioned based on maximum throughput at peak periods. So the shopping center throughput is highest during Christmas time. And that's how you generate your BTS capacity. But it is sitting there all year round. So most of the capacity will be in idle mode most of the year. And the same happens for a convention center. It's only full during a convention. So now we try to change the setup of such a system. That means we involve a switch between the base station capacity and the site. The switch allows you now to switch capacity to places where it's needed, and that means, see the change in the following slide, we are able to reduce base station capacity. So we can take out base stations because the overall amount of capacity needed in this campus is lower than the previously installed capacity. Or in other words, the individual capacity peak demand, if you take it as a sum of all these individual zones, is higher than the actual total capacity needed at the single time in this campus. So here is a cost reduction by reducing base station cost, capacity fed into the system, and it's not the base station only, it's all the network behind it, the BBU, it's the MSC's infrastructure, these lines, and everything contributing to the cost. So what happens now when we use the shifting approach? For example, here we deploy capacity to the shopping mall during evenings, during weekends. We are taking capacity from the hotel, taking capacity from the office tower, and feed it into the ground level where the shopping center is located. Another scenario is that there is a conference at the hotel. Now we can use capacity, for example, from the office tower or from the shopping mall, and feed it into the hotel to have more capacity available. I think this makes clear what capacity shifting means. With less BTS resources, with less sectors, you are able to satisfy the same capacity demand in the network. Another scenario looks more on a macro shift, applying the same concept, but now we have a centralized base station hotel in this purple rectangle in the center, and this base station hotel is feeding, for example, a university. At other times, capacity could be directed to a hotel or to a conference center or to a stadium. That means now you're not looking on a campus, you're looking on a larger area of a city where you could use capacity more effectively and share it between venues that require a high amount of capacity. So the key benefits of idDAS, first of all, it's modular and flexible, and this is essential in my opinion because of the changed market behavior. Since the data growth is so quick in networks that you have to increase your network capacity 10 times over 3 years, that means that your write-off periods don't match really anymore with the real-life scenarios. Usually write-off is 8 years for equipment, telecom equipment, but it doesn't help if you have to replace it every 3 years. So idDAS is a system that can be upgraded. It can be added in terms of capacity, new bands, MIMO, for example, so it grows with the demand. It's an investment that survives longer than 3 years, that is able to grow with your capacity demands, and that means it's ideal to follow the future growth scenarios that we see. And it is optimized for multi-operator use. That means that in difference to existing similar solutions using remote radio heads, using small cells, idDAS can support multiple operators, and this is typically what we see in situations like metros, like in-building, like stadiums. It's typically a multi-operator deployment. And at the same time, it's multi-band. So idDAS is not limited in number of bands. It could support 5 bands, as we usually find in the Europe, Middle East, Africa region. But it could even support 8 bands in Asia Pacific in Australia, for example, and it can support MIMO. So it's easily expandable. It's plug and play. We try to make it as easy as possible to use. There is a wizard how to interconnect cables when you install the system. There is indicators how much capacity each link is using, if there's saturation or not, if there's margin. So it's very user-friendly. And it's wireless technology agnostic. That means on every band idDAS is supplying, you can use, for example, 2G, 3G, 4G. It supports cellular and public safety on the same network. That means you can actually bundle a typical public safety requirement with a cellular deployment, which reduces network cost, allows entry into buildings that might be blocked to cellular operators and come in with the public safety offering, for example, or as public safety is needed in most countries today as a minimum requirement for in-building, it could be added to the cellular deployment, reducing cost, increasing efficiency. And this is without interference between the systems, because this digital approach is totally isolated, isolating the bands from each other so that there is no interference. One very good thing is that idDAS is reducing infrastructure costs, which is the cable, the connections between the equipment. Traditional DAS needs single-mode fiber usually. Some systems multi-mode, but it never allows to use multiple media. Digital DAS, idDAS, allows to use single-mode fiber, multi-mode fiber, and twisted pair. And the other good thing is that this doesn't need to be predefined. All this is based on the SFP Plus modules that you see on the left side. SFP Plus modules are standard components used in the IT industry. That means we just qualify them, we test them, and supply them to you. And you select on an individual basis if you want to run a single mode 10-kilometer link, or a multi-mode 300-meter link, or perhaps a twisted pair link. And it's future upgrade guaranteed, because there might be, for example, a Cat7 standard soon, and then there will be SFP Plus modules available for the standard, and we can follow with the availability of new media types. idDAS improves network performance because we do an excellent noise management. In a shared DAS, in a multi-point DAS, you usually have noise issues. Each remote unit contributes noise in the uplink, and if one of them is not balanced right, it will dominate over the others and contribute more noise than the others to the base station, which sets the lowest sensitivity level in the network. idDAS does this automatically in an optimized way, that every remote unit appears with the same noise level at the base station at the minimized level. Further, the digital transmission over fiber has an advantage over analog transmission. That means the noise contribution is lower, and that again adds to lower noise, which means throughput. And throughput is essential in 3G, 4G networks. So it's all about throughput, and that's how your customers will rate the system quality at the end of the day, and that means noise needs to be minimized. MIMO can be used on the same fiber. So a single fiber to a site can support MIMO. Not only SISO as today, it will allow you to add MIMO. idDAS is user-friendly and in-building friendly. That means we maximize the use of existing cable infrastructure. So in many buildings today you find multi-mode fiber, and it is relatively low cost to use this fiber. idDAS allows to use that wherever wanted, even twisted pair, and for long hops, it's single mode fiber. And compared to the past, where anchored connectors had to be used for analog transmission, anchored connectors 8 degrees, it is not required anymore for idDAS. idDAS uses straight connectors like used in all the other digital telecommunication industry, and that's a big advantage as well. It's a future-proof design, because building owners just make the installation once, and once it comes to band upgrades, capacity updates, the same infrastructure can be used. idDAS is made to be aesthetical in terms of view and noise emissions and so on, so it's non-obtrusive and no extra fiber needed for MIMO. Technology agnostic, supporting all modulation schemes available. And we provide a kind of a VPN approach per operator. So every operator and every technology has an own digital channel inside the network, a virtual channel inside the idDAS digital environment. And that means those channels are isolated from each other, can't be seen from outside and adjusted from outside from anyone who is not allowed to do so. So it's like a VPN connection from the base station to the remote unit. We minimize RF interference because all the combining is actually done on the digital domain. There is not much combining required on the RF side, and combining, we all hear that, generate pins or increases the risk of pin. So pin is taken care of in this system approach. We try to minimize it by doing the combining on the digital side, which again results in higher throughput in the uplink. There is an additional transport channel in idDAS that allows to connect Wi-Fi or small cells anywhere where it's needed. So this could mean that you add a future LTE standards to a metro in a station, for example, 3.5 gigahertz, which doesn't exist in most countries today, but once available, you have the choice of adding an idDAS element to support it or adding small cells to support it, or Wi-Fi, which is a common requirement today. idDAS enables to quick and easy calibrate the equipment, commission this system. Commissioning takes quite a lengthy process today, for example, for a metro system, for a stadium, and commissioning ability of idDAS reduces manpower and increases transparency, so you can see from one central point what the system is doing. You can add sectors, change sector allocation easily, remotely, add MIMO capability wherever required. So this remote change ability of the system is a big difference to previous analog DAS systems, because there it was a hardwired approach. You were able to change capacity distribution in the analog DAS system, but you had to go to the site to change wiring to do that. So you would do it not on a short-term basis. With idDAS, you can do that just for an hour, for example, remotely, and then change it back to the previous setting, and that's a big advantage. Let's take a real-life scenario. Actual Wireless supported the Olympic Games in London in 2012, and it was the Olympic Village that we supported from the central base station hotel. In this central base station hotel, we had 972 BTS sectors. So that's almost 1,000 BTS sectors that were feeding this system. And this capacity was distributed to 350 remote units. This was done in a hardwired fashion because it was analog DAS. That means every single stadium in this village had to be optimized for maximum throughput. That means when it's full. But I think we all agree that not all of the stadiums connected to this base station hotels were full at the same time. So some of them were empty in idle mode. So all these base station sectors for that stadium were in idle mode and not used, not generating airtime, not generating revenue for the operator. So with idDAS, you would be able to reduce the number of BTS sectors and still cover the same area with the same capacity. Based on my estimation, it would be a reduction from 972 to something like 550 base station sectors. And here you can see the enormous reduction of CAPEX and OPEX using idDAS. By the way, if you look on these almost 1,000 BTS sectors, this was done in a time when there was no 4G in the UK. It was only 2G and 3G. You can imagine how many sectors it would be today with 4G. It would be much more than 1,000. And that shows the dimension of such a project, which is quite typical for a distributed antenna system. So with idDAS and capacity switching. Fewer base stations would be needed. The differentiation by service, increased flexibility to move data coverage and still keep GSM background or UMTS background for voice, and the dynamic allocation of capacity. So this is an improved user experience, moving capacity where the hotspots are. That means you can really follow with your subscribers and supply capacity where your subscribers are. Through IP backhaul and cable agnostic approach, we could have used much easier integration using Wi-Fi integration, for example, using existing fiber infrastructure, reduce rollout cost. And due to the sharper filtering, due to the digital approach, there would have been reduced interference and better network performance, better throughput. So let's have a look on idDAS, how it really is appearing when you see the different modules. We basically have remote units on the right side. We have two power classes. We have idRU30, which is a medium power version. We have idRU40, high power versions, up to 20 watts RF power. They have one thing in common. Every cabinet supports 4 bands, 4 RF bands. As you can see on the lower example, we can cascade 2 units. 2 idRU30 units are connected together to provide MIMO, for example, or to provide 5, 7 band support or 8 band support. Connected to the idRUs can be small cells, Wi-Fi access points, and so on. Then when we move left, we see the MSDH, which is a switch. It's a CPRI switch. The CPRI switch that allows to switch capacity from base stations to any point in the network where it's required. The switches are being fed by MSDH, by MTDIs. And those MTDIs have the function to digitize signals, RF signals, that are introduced to these MTDI modules. So the base stations that you see on the left side are connected through an APUI, which is an advanced point of interface, adjusting levels and so on, doing certain things to the RF signals to make it user-friendly, to balance the signal levels and so on, and feed it to the digitizer, to the MTDI. So from the MTDI onwards, it's CPRI. All the yellow lines are CPRI signals. So CPRI means it's switchable packets. So between the MTDI and the MSDH, we can switch. We can switch between the MSDH and the idRU. And the distance between those elements depends on the chosen media type. So if it's single mode, we look at up to 40 kilometers distance at the moment, which is a huge improvement over previous analog DAS. Active point of interface, we use it already today in analog active DAS systems, is adjusting up to 16 base station sectors in power, in gain. It's remote accessible. It supports SNMP, and it allows to see what signal levels are coming from the base station remotely. And you can adjust the gain and power settings remotely. You can set alarm thresholds in case one base station suddenly generates more power than another, and feed this alarm to any monitoring system. All our products have a web server on board to monitor them, so it's a very nice way to interact with them on the graphical user interface. The digitizer, the MTDI, has again 16 ports, is modular, and has 2 CPRI ports as an output. So it's RF in, CPRI out. Then we come to the multi-sector digital hub, the CPRI switch. CPRI switch has 16 ports, 16 CPRI ports, and it allows any connection between these ports, multiple cable types, single mode, multi-mode, and twisted pair. It has also 16 Ethernet ports, and I guess you know what they are used for. So each input on these Ethernet ports feeds to the related remote unit on the SIP report. So it's up to 1 gigabit per second data capacity on these Ethernet ports, and those are used to support Wi-Fi, for example. It could be a small cell. It could be also video monitoring or advertising boards at the remote sites. There's a whole range of typical applications. And the other good thing about this Ethernet ability is it's future-proof. So anything that might come up in the future can be supported using this Ethernet transport channel. So coming to the remote units here, the medium power version with an optimized cabinet, a small cabinet. It is convection cooled, so we have a fanless approach. We try to make every product fanless whenever possible, and that means less maintenance, no noise emissions, and higher availability. So all these remote units have SIP ports. They have 2 of them, one to connect to the server and another one to connect to the next remote unit to cascade it, and a 1 gigabit transport channel for IP-based services. The idRU40 high-power unit is a bit bigger in size because, again, we make it passive cooled in most times. There are just a few models with very high RF power that require fan cooling, which is a fan hood that goes onto this standard cabinet, so it's very easy to deploy and add in the field. So this unit goes up to 43 dBm or 20 watts in power. So that was the product introduction. There is, of course, much more to say about it. And what we typically do, if there is an interest on your side, we give you a detailed presentation showing much more than I was able to show here in this public presentation today. And believe me, it's a very exciting platform, a very exciting technology. We get great feedback from customers and people who are interested in such an approach, and we would be really happy to bring it closer to you. Please feel free to contact me on the email address or any of the sales representatives that you see, or look on our webpage, which shows more about it. And we have now some time to answer some of the questions. I'm sure that there will be more questions than we can answer. I want to use the opportunity already to thank you for your participation, and hope to see you soon and give you more details. So now back to Ben to see if, what questions there are.
Thanks, Ingo, and thank you everyone for listening today. Have some great questions, so we'll get right on to those now. So Ingo, the first question we have is, with the availability of remote radio heads and micro base stations, is there a sufficient business case for idDAS?
That's a good question, because that's exactly the point. Why is there idDAS? idDAS has one big difference to these mentioned technologies. It's multi-operator capable, and that we underline 3 times. Any technology you find from the OEMs, from the base station vendors, are single operator technologies today. And the reality is that especially the high-level projects are done multi-operator today. That's a general trend that we see more and more, and it's established in metros, in stadia, in shopping centers, basically in all the high-capacity projects. So that's where our strength is. We support multiple operators.
Okay, that's great. Thanks, Ingo. The next question we have is the capacity diversion managed or automated? If it is managed, is there a management cost associated?
Yeah, that's another good one, because this dynamic capacity allocation, a lot of customers where we introduced this solution were afraid of this word dynamic. And how dynamic it is, it's fully under your control. So there is no additional software required or service fee required to have it. idDAS offers a capacity management. How you want to use it, it's your choice. The most simple example would be a scheduled changed. Let's say you have an office tower and a shopping mall. That means in the office tower, you need capacity from 8 in the morning to 5 in the afternoon. After that, you reduce capacity from the office tower and put it into the shopping center. So that's a very simple example on a daily routine. It could be changed during weekends, so it's a very easy scheduler. Another way to do that is that you measure traffic in your NOC, and then you manually change the capacity distribution. That means you dial in to the server of idDAS and you change the capacity routing. And then we see different future possibilities to automate that. One could be to connect to an external zone server. Another way to do this is measure capacity and traffic inside idDAS, because we can very well measure the traffic that is going through our links, and based on that could offer you algorithms that change the traffic distribution. But one thing is important. In all of these scenarios, the operator needs to have the final say and the control of this, because it's about neighbor relationships and so on. There are a lot of things to consider. So every capacity change needs to be pre-approved by the operator, so idDAS is only doing what the operator wants it to do. Thanks for that.
Great, Ingo, thank you. The next question we have is, can existing L2 hardware be used with idDAS? For example, can the CIPRI connection run over an L2 switch, or is there a dedicated cable needed?
The cable is not dedicated for idDAS. I hope I got the question wrong. So the interconnection between the units uses standard media types like single-mode fiber, like multi-mode fiber. The only thing that we add to this is the SFP Plus module, which is again a standard device in the market. But the reason why we need to distribute it is because we need to test it and verify it upfront that it fully works with idDAS, and that's why you buy it through us. And but the media type itself, the cable and so on, it's neutral. It's not vendor specific or anything. Thank you.
Okay, thank you, Inge. The next question we have is, can we support 4x4 MIMO, or only 2x2? And is the idDAS MIMO capable over Cat 5 and 6?
So there are actually two questions. One is the MIMO question. There is no limitation for idDAS in terms of the complexity of MIMO. We see today 2x2 MIMO, and I have my doubts that 4x4 would be used for in building because of the cable cost and so on, but why not for a macro site or a street site DAS? idDAS supports 4x4 MIMO. It would even support 8x8 MIMO because it's a simply addition of RF devices. That means remote units, and that means if you have 4x4 MIMO, you need 4 times the same amplifier in the same frequency. So this could be done in one box, it could be done in 4 boxes, and they are daisy chained together. There are multiple ways to do that, but there is no limitations in terms of complexity when it comes to idDAS. But there is another limitation, which is a link throughput, and that relates to the twisted pair Cat 5 or 6 question. The link to the remote unit defines how much capacity can be carried through this link. Under normal circumstances, this is about 274 megahertz RF bandwidth. So you can collect up to 274 megahertz at the base station sectors in the base station hotel, and this can be fed over one single link to one site, and then it will be distributed between the individual remote units or MIMO remote units. If you need more, there is no problem. You simply activate a second link to that site, and then you have double capacity, so there is no issue. But now coming back to the Cat 5, Cat 6 question, since Cat 5e or Cat 6a is limited in throughput and capacity, and we're just looking on these 2 or higher standards, meaning they might support only 1 gigabit per second, it would mean that you just have the 1/10 of the RF bandwidth that could be carried over a typical Cat 5e cable. But when it comes to Cat 6a, it already supports 10 gigabits per second, and it's the same throughput as we see on optical fiber. And all future twisted pair standards should be higher in throughput and will be able to support this high throughput rate similar to fiber. However, there is another limitation on twisted pair, which is the range. It's specified for a range of 100 meters only, while I said for single mode fiber it can be 40 kilometers of range. So this means you have to look on the requirements for each link, and the advantage of idDAS is you can optimize the cost for each link based on the actual requirements. I hope this was clear. It was quite a long answer, but thanks for the question.
Thanks, Ingo. We have another question, actually a follow-up to the business case that we posed with the multi-operator scenario. With multi-operator solutions being a key driver for DAS, overall, what is the business case, if any, for a single operator scenario?
Can you repeat this question, please?
Sorry, so what is the business case, if any, for a single operator scenario rather than a multi-operator scenario?
Okay. Yeah, of course, for a single operator, it's more difficult to justify an investment. However, we see big opportunities because there are advantages even for single operator. idDAS allows to bundle bands. idDAS allows to have up to 4 RF bands in a single cabinet, which no known remote radio head or small cell technology is able to provide today, at least to my knowledge. They're limited to 1 or 2 bands. So there is definitely an advantage in terms of number of cabinets and in terms of cost using idDAS for single operator application. And another thing that we don't see really in the OEM offerings today is the cloud RAN approach, which idDAS fully supports. That means capacity switching. You can freely decide if a single base station sector ends at 1 remote unit, at 5 remote units, or at 20 remote units. And that's something that is a clear advantage of idDAS. And we see advantages even for single operator cases. Thank you.
Thanks, Ingo. Question relating to frequency bands now. Which frequency bands are available for idDAS, and is it possible to accommodate Tetra or UHF systems?
Yeah, another good one. So since we are looking on an EMEA auditory here, we offer all EMEA bands for cellular 800, 900, 1800, 2100, 2600. To show you the flexibility of idDAS, we do much more than that. We cover the full US requirements, the full Asia Pacific requirements, and in Australia we are talking about 8 bands for idDAS. And that means we are basically totally flexible when it comes to new bands. Regarding public safety will happen. We have not released products yet, but we see great market interest, for example, from last Critical Communication World in Barcelona. There is a great demand for this approach because we can, for example, combine Tetra and LTE for public safety today. LTE is supported already. With UHF, VHF, we do not have the amplifiers integrated in idDAS today, but this is really just the logistical efforts to do, and it requires a business case. So we are currently concentrating all our efforts on the cellular bands, but there is no reason why we couldn't do public safety, and it will come sooner or later. I just can't place it on the roadmap today. Thank you.
Thanks, Ingo. Our final question for today is, where does the switching take place? Is it the MTDI or at the router?
Well, it's actually the MSDH router that does most of the switching, but it's not limited to it. Just imagine the remote unit can be selective as well. Let's say you pump a whole trunk of data onto a link to one remote unit, which connects to a second remote unit. Each of these remote units can extract the wanted traffic profile out of this packet stream. So there is at least selection ability in all the devices, but the switching and routing itself is mostly done in the MSDH. Thank you.
Thanks, Ingo. That's all the questions we have today. So thank you everyone for joining us on the webinar. And if you have any further questions, please don't hesitate to contact us. Using the information you see on your screen at the moment, you can contact Ingo directly. Great, thank you.
Thanks everyone. Bye-bye.